Hey, champs of exam. Welcome to the question series of Examsnet. Students, you must have explored our website www.examsnet.com. This site is a great place for you to practice your entrance exam question papers because here you will find not only this but similar type of multiple entrance exam question papers. For better preparation of your exams, you must download our app. The link is available in the description box. So today students will be solving the AP EAPCET 16 May 2023, Shift 1 paper. I'll be solving the chemistry questions of this paper in this particular video. So here we go with the first question of the chemistry section for this particular paper. A very best of luck. Here we go. So you have to match the elements of list 1 with the list 2. List 1 contains the elements and list 2 contains the valence shell configuration. All right, let's talk about the first one. That is the alkali metals. Alkali metals, they are having the configuration, valence shell configuration as NS1 because they are very much likely to gain one electron to, to lose one electron to gain its inert state. So this is NS1 because one electron, it is very easily, it is very capable of losing one electron. The alkali metals, this is A. And next are the alkaline earth metals. They have an S2 because they can easily leave two electrons to complete their valence shell. So this is the one. Next are the halogens. Halogens are this. So chlorine, fluorine, like they are the halogens. This is NS2, NP5. They have very much a tendency to gain one electron to complete its octet. So this is C. And this was your B. Noble gases, they don't participate in any of the reaction, so their outermost shell is complete. This is NS2NP6. So this is your D. That makes, let's check with the options, which one is the correct one. Option B stands to be the right answer. Hope you understood this. Next is question number 122. Which of the following electronic transitions in hydrogen atom will require the highest energy? From n is equal to 4 to 5, 1 to 2, 3 to 5, or 2 to 3. The highest energy will be required during the transition of electrons from the first to the second shell. It is because as the energy level increases, energy gap decreases progressively. So you have option B as the right answer. Hope you understood this. Next is question number 123. Correct order of the basic strength of metallic hydroxides is. So you have all these options before discussing all these options. Question number 123. Correct order of the basic strength of the metallic hydroxides given over here are like what? Okay, you have three, basically, you have three hydroxides over here. You have cerium hydroxide, lutetium hydroxide, and europium hydroxide. Also, as the size of the metal atom, size of metal atom increases, their metal oxygen bond length also increase. And the tendency to lose hydroxyl ion also increases, due to which the basicity also increases. Now, if I talk about these three metals, cerium, lutetium, and europium, you have lutetium, then europium, then you have cerium. So this is the order of the size of the metallic elements. And according to this, their basic strength will be the same. This followed by europium hydroxide, followed by cerium hydroxide. And that is option C. So this is the right answer to the question. Hope you got that. Next is question 124. Which of the following oxides is highly basic? So you have these three hydroxides. Okay. On moving from left to right in a period, the basic character increases. This refers to basic character, decreases. Thus, among you have four elements: sodium oxide, magnesium oxide. Magnesium oxide is less basic. While if I talk about aluminium oxide and chromium oxide, they are the amphoteric oxide. So sodium hydroxide is most basic oxide among all the given options. So you have D option as the correct answer. Next is question number 125. Which of the following fluorides of xenon does not exist? You have xenon fluoride, XeFe3, XeFe2, XeFe6, or XeFe4. Among this, option A does not exist. Among all the given fluorides of the xenon, only XeF3 does not exist. It is because it will form odd electron species, which is highly unstable. So option A is the right answer. Hope you understood this. Next is question 126. Correct order of bond angles of the following is. So we are talking about the bond angles of all of them. Let's first of all pick up the water. So water is having 2 into 1. First of all, let's pick up water. So you have this as 2 into 1 by 2, 6 minus 2. That means here you have 2 bond and 2 lone pairs, right? So that means the shape is bent and the angle will be and angle will be 104.5 degrees. And the second one, you have NH3. So this is 3 plus half of 5 minus 3. That means it is having 3 bond pair and 1 lone pair. And that makes the shape as trigonal pyramid. Trigonal pyramid. So the bond angle will be 107. The third one, you have CH4. This is 4 plus half of 4. That means it is having 4 bond pair and 0 lone pair. And the last one, that is, which was it? SO2. So, okay, there's a shape over here. Shape will be tetrahedral. So the angle 109.5 degrees. The last one, that is your SO2 sulfur dioxide. This is 2 plus half of 6 minus 4. This is 2 bond pair and 1 lone pair. That means the shape is trigonal planar. Shape is trigonal planar. Therefore, angle 119 degree. So you have to find out the angle order. So I think this is the largest one, sulfur dioxide. And that is followed by this, then this, and then this. So you have 4, 3, 2, 1. That is option A. You have first option as the right answer. Hope you understood this. Next is question number 127. A, B, C. Identify the correct statements from the following. A says the compressibility factor Z for an ideal gas is 1. Okay, let's see. The compressibility factor Z is given by PV upon nRT. And for an ideal gas, you know, they both are equal for ideal gas. So that means Z value will be equal for an ideal gas. So this is correct. A is correct. Second one, uranium isotopes, this and this are separated by converting them into UF6 vapors. Uranium isotopes U-235 and U-238 are separated by converting them into UF6 vapors. This is correct. Let's go for the C. Decrease in temperature increases the kinetic energy of the gas molecules. No, kinetic energy of the gas molecules is directly proportional to the temperature. So with a decrease in the temperature, the kinetic energy will also drop. That is, C is wrong. That means you have A and B as correct, which makes option D to be the right answer. Hope you understood this. Next is 128 question. At a given temperature, the density of the ideal gas is proportional to. Your P refers to the pressure of the ideal gas. Ideal gas equation says PV is equal to nRT, or you have PV is equal to N is given by mass upon molar mass of the element, molar mass into RT, or you have P is equal to mass upon volume multiply RT upon M. Here M is your molar mass. So you have P is equal to, say that's T RT upon M, because I have taken this, mass upon volume is nothing but density, D. Let's say that equal to D. So that means from here, this pressure is directly proportional to density, or density is directly proportional to pressure, one of the same things. So at the given temperature, density is directly proportional to the pressure. Option B is the right answer. Hope you got that. Next is question 129. The weight percentage of CNH in hydrocarbon is in the ratio 4:1. What is its empirical formula? Weight ratio of C and H is equal to 4:1. It is given to you. And the molar mass of C and H, this is 12:1. Now the ratio of weight ratio and the ratio of weight ratio and molar mass ratio of C is to H is given by weight ratio C upon H upon molar mass ratio C is to H. That is 4:1 upon this. This will give you 1/3. That means for every carbon atom, there are 3 hydrogen atoms. This will be the empirical formula. CH3. For one carbon atom, there will be 3 hydrogen atoms. CH3, option C is the right answer. Hope you understood. Next is question number 130. The standard enthalpy of sublimation is, sorry, I'm repeating. The standard enthalpy of sublimation given by this of solid carbon dioxide, naphthalene, lithium, and sodium are this, respectively. Order of sublimation of these substances with temperature is. So you have standard enthalpy sublimation as for carbon dioxide is 25.2 kilojoules mole. For naphthalene, 73 kilojoules mole. Lithium and sodium. For lithium, this is 162, and for sodium, it's 108 kilojoules mole. The order of sublimation of these with the temperature will be order of sublimation of these with temperature will be given by solid carbon dioxide, naphthalene, sodium, and lithium. It is because less is the value of the standard sublimation enthalpy, more easily it will undergo sublimation. That means we have C option as the right answer. Hope you got that. Next is 131. When X gram of graphite is completely burned in a bomb calorimeter in excess of oxygen at 298 Kelvin, 1 atmosphere pressure as given by this equation, the temperature of calorimeter raised from 298 to 302 Kelvin. If the heat capacity of the calorimeter and the molar enthalpy change for the reaction at 1 atmosphere 298 Kelvin are this and this, then what is X in grams? Okay, let's write down the reaction first. We have the carbon, which is in the graphite form. Oxygen, gaseous, will give you carbon dioxide, which is gaseous. So delta Ng will be 0. Weight of graphite is X. Weight of graphite is equal to X. Here you have T1, 298 Kelvin, T2, 302 Kelvin, CV as 20.7 kilojoules per Kelvin. Molar enthalpy change delta E is equal to minus 248.4 kilojoules per mole. Now heat evolved at constant volume is given by at constant volume is given by QV is equal to minus C delta T. This is equal to minus 20.7 and the change in temperature is this much. This is equal to minus 82.8 kilojoules per mole. So you have delta E. So also delta E is equal to QV upon N. So minus 248.4 is equal to this. And N is given by mass upon the molar mass was equal to 12. And let's solve this. You have minus 248.4 multiply this is equal to minus 82.8. So you have mass as minus 82.8 into 12 divided by minus 248.4. This will be equal to, on solving, will give you 4 grams. Therefore, mass of the graphite is 4 grams. Option D stands to be the correct answer. Hope you got that. Let's move to the next question. Question number 132. 1 mole of PCl5 gas was heated in 1 liter of closed flask at 500 Kelvin. At equilibrium, 0.1 mole of chlorine gas was formed. What is the Kp in atmospheres? Okay, let's make the reaction. First of all, PCl5 in the gaseous form. This changes into PCl3 if the chlorine gas is to be formed. So PCl3, PCl2, both are in the gaseous form. So 0.1 mole of chlorine is formed. Similarly, if this is 0.1 mole, this is also 0.1 mole. PCl3 is also 0.1 mole. And PCl5, which is already, in the beginning, it was 1 mole, 0.1 mole has been taken out. So this is now the value, the moles, number of moles for PCl5 will be equal to 1 minus 0.1. This is number of moles at equilibrium. This is, I'm talking if the equilibrium is attained. Right. Next, you have the Kc as this will be the concentration of PCl3 into Cl2 divided by the concentration of PCl5. This is equal to 0.1 into 0.1 upon 1 minus 0.1. This gives you 0.9. That is equal to 1 by 90. Now we know that Kp is equal to Kc into RT power N, where N is the number of moles of gas, R is your gas constant, T is the temperature, and Kp, I have to find out. Kc, we just solved, this is 1 by 90. R is 0.082 kilojoules per mole into 500. This will give on solving, this will give you the value of Kp as 0.455. So you have B option as the right answer. Hope you understood this. Next is question number 133. Conjugate acid and conjugate base of hypochlorate ion are. So this is the one. If I have to make the conjugate acid of it, what I have to do, I have to add the H plus ions. So hydronium ions I have to add over here. This will be H2CO3. This is the carbonic acid. You will get this one. And here, if I'm removing, but this is your conjugate acid. And for making the conjugate base, I have to remove the H plus ions. If I remove H from here, you will be left with only the carbonate ion. So this is your conjugate acid and this is your conjugate base. You have the option as the correct answer. Hope you understood. Next is question number 434. Among the following, the correct statements are lithium hydride, beryllium hydride, magnesium hydride are saline hydrides with significant covalent character. 2. Saline hydrides are volatile. No, saline hydrides are not volatile. This is correct. Lithium hydride, beryllium hydride, magnesium hydride are saline hydrides with significant covalent character. That's correct. Third one, electron precise hydrides are Lewis spaces. No, the correct formula for chromium hydride is CRH. This is also correct. See, statement 1 and 4 are correct, whereas 2 and 3 are incorrect. It is because the saline hydrides are non-volatile, non-volatile, non-conducting, crystalline solids. Crystalline solids. As electron precise hydrides are neither Lewis acid nor Lewis base. So we have only 1 and 4 as the correct, and the second and the third are wrong ones. So the correct option is 1 and 4. That is C option. Hope you understood this. Next is question 135. White metal is an alloy of lithium and magnesium, lithium and lead and lead and aluminium. White metal is an alloy of lithium and lead. That's it. Option B. This is the right answer. Next is question number 136. Which of the following statements are not correct? Number 1, atomic radius of gallium is less than that of aluminium. This is correct. Atomic radius of gallium is less than that of aluminium. That's right. Question number 136. Which of the following statements are not correct? First of all, atomic radius of gallium is less than aluminium. This is correct. Atomic radius of gallium is definitely less than aluminium. Second one, the order of ionization enthalpy of group 13 elements is given by boron greater than aluminium, greater than gallium, greater than indium, greater than thallium. This is wrong. The correct order is given by boron, then thallium, gallium, aluminium, and indium. So this one is wrong. And next one, boron trioxide is amphoteric in nature. No, this is acidic in nature. So these two are incorrect ones. That means option A is the correct answer. Hope you understood. Next is question 137. Identify the correct statements from the following. Number 1 says melting points or the boiling points of group 13 elements are much higher than those of the corresponding group 14 elements. No. You have to find out the correct statements. See, the melting point and the boiling point of group 14 elements are higher than group 13 elements. So this is opposite. This is wrong. The second one says silicon oxide only exists at high temperature. This is correct. Silicon oxide exists only at high temperatures. Then is this is Bi4 or lead 4 oxide. This does not exist. Right, this is correct. This does not exist. Next is Buckminster fluorine contain 12 6-membered carbon rings and 25-membered carbon rings. See, Buckminster fluorine contain 12. It is, wait, it contains 12. Actually, here should be 5. 12 5-membered carbon rings and 26-membered carbon rings. Membered carbon rings. So first is incorrect and the fourth is incorrect. That makes D option. Wait. What we had to find out was correct ones, right? Okay. So you have the second as the correct and the third as the second and the third are the correct ones. This is option C. I'm repeating. You have to find out the correct statements. The second statement was correct and the third statement was correct. So you have option C as your answer. Hope you understood this. Next is question 138. So you are given this reaction. In the above reaction, electrophile is substituted at meta position only due to electron density is more at ortho and para position. No. First of all, let's make the complete this reaction. This is okay. This is nitrogen dioxide over here and question number 138. You are given this reaction. In the above reaction, electrophile is substituted at meta position only due to electron density is more at ortho and para position. No. Electron density is relatively less at ortho and para position. This is correct. Electron density is less at meta position. No, it is relatively more at meta position. So you have second and fourth as the correct answers. That makes option B as the correct answer. Hope you understood this. So that means if the electrophile is substituted at meta position only. So let's move to the next question, number 139. IUPAC name of the following molecule is. So look at the molecule very carefully. You are having, okay, here is question number 139. You have to tell the IUPAC name for the following molecule. Let's go. That's number 1, 2, 3, 4, 5, 6, 7, 8, and 9. I have numbered the carbon atoms. They are a total of 9 carbon atoms. Let's name at the fourth one, you are having a bromine atom is attached. So 4 bromo, 6 one is having a chlorine attached to it. So 6 chloro. And then you have 3 and 7. They are having the ethyls. So this is diethylnone and 7 and 1 ion 5 1. So this is option D. So hope you understood that. Let's move to the next question. Question number 140. Out of 7 crystal systems, how many are face-centered unit cells? Okay, out of 7 crystal systems, the face-centered unit cells are present only in 2 crystal systems. And those are cubic and orthorhombic crystal systems. So the correct answer to the question is option B. Hope you understood this. Next is question number 141. What is the osmotic pressure in atmosphere of 0.02 m aqueous glucose solution at 300 Kelvin? You're given the value of R to be this. Okay, so in the question you are given C is equal to 0.02 m and the temperature 300 Kelvin. R gas constant is this much liters atmosphere per mole per Kelvin. So osmotic pressure is CRT. On substituting the given values, you will have the osmotic pressure is equal to C is equal to 0.02. This is equal to this and temperature 300. On solving, you will have 0.492 atmospheres. That is B option. This is the right answer. Hope you understood. Next is question number 142. The elevation in the boiling point of the aqueous urea solution is 0.014 Kelvin. What is the delta TF in Kelvin? For water, you have to take KB as this and KF as this. Okay. So, now in the given question, you have a delta TB is equal to question number 142. The elevation in the boiling point of the aqueous urea solution is this. What is the value of delta TF in Kelvin? You are given for the water, K backward is this and forward is this. Okay. So you have the change in temperature for the boiling point. So delta TB is equal to 0.104 Kelvin and KB is given as this much kilo kg per mole. And K forward is 1.86 kilo kg per mole. And you have to find out what do you have to find out delta TF. This is what you need to find out. So let's use the formula. You have delta TB is equal to KB into M, where M represents your molality. M becomes equal to delta TB upon KB. Let's fill in the values. You have this as 0.014 upon 0.52. On solving, this will give you 0.5 M. So substituting the value of molality in the given equation, that is substituting, this is the molality. Substituting this value in the equation, delta TF is equal to KF into M. Or this will be KF is given 1.86 M. We just calculated 0.2. This is answer is in Kelvin. On solving, this will be 0.372 Kelvin. So this is the answer to the question, 0.372 Kelvin. Option C is the right answer. Hope you understood this. Next is question number 143. Molar conductivity is at infinite dilution for barium hydroxide, barium chloride, and ammonium chloride are this, and this, respectively. Then the molar conductivity for ammonium hydroxide is. Question number 143, molar conductivities at infinite dilution for barium hydroxide, barium chloride, ammonium chloride are this, respectively. You have to find out molar conductivity at infinite dilution for ammonium hydroxide. Let's write down, you are given that molar conductivity for the infinite dilution of barium hydroxide is equal to 457. And for barium chloride, it is equal to 240.6. And for ammonium chloride, this is 2130. You have to find out molar conductivity for the infinite dilution of ammonium hydroxide. So let's find out that molar conductivity for the infinite dilution of ammonium hydroxide is equal to 2 into this ammonium chloride plus for barium hydroxide subtraction for barium chloride, whole thing divided by 2. Let's fill in. You have this 2 into 2130 plus 457 minus 240.6 upon 2. So this is equal to, on solving, it will give you 4476.4 upon 2. This value. So this is equal to 2238.2. This is the answer. So you have option D as the correct answer. Hope you understood this. Next is question 144. The time required in hours to reduce 3 mole of ferric ions to ferrous ions with 2.0 amperes of current. 1F is given to you as this value. So you are given that current is 2 amperes. The reaction involved in the reduction of ferric ions to ferrous ions is given by this. So ferrous if I'm adding 3 electrons to it, I will get ferric ions. Ferric, I'm adding 3 electrons to it, I'm getting ferrous ions. So here will be 3, here will be 3. Gives the balancing. Charge required because 3 ions are involved. So charge required will be 3 into 96500. That is equal to 289,500 coulombs. Also, we know that charge is equal to current into time. So you have time as charge upon current. This is equal to 289,000. Current is 2. So this gives you 144,750 seconds. Or if I'm converting into hours, this will be 40.21 hours. That makes option B to be the right answer. Hope you understood this. Next is question number 145. Which of the following is an example of multimolecular collide? Multimolecular collide. They are formed by a large number of atoms or small molecules of diameter less than 1 nanometer of the substance, which on this solution aggregates together to form species having size in the colloidal range. So, for example, this can be sulfur solution. Let's write it down. So, multimolecular colloids are formed by a large number of atoms or small molecules of diameter less than 1 nanometer of a substance, which on dissolution aggregates together to form species having size in colloidal range. In colloidal range, for example, sulfur solution. Option A. This is the right answer. Hope you understood this. Next is question number 146. Consider the following reactions. The catalyst here, A, B, C, are respectively. Let's see the first reaction. Carbon monoxide reacted with hydrogen gas in the presence of here. A is nickel. In the presence of nickel gives you methane and water. This is in the gaseous form. Let's write down these equations over here. So you have carbon monoxide. This is in the gaseous form plus hydrogen, of course, in the gaseous form. This reacts in the presence of nickel. This is the catalyst. This gives you methane in the gaseous form plus water in the gaseous form. So let's do the balancing. This will be 3 and yeah, it will be done. So the next one, carbon monoxide gas plus H2 gas. In the presence of zinc oxide, chromium oxide gives you CH3OH in the gaseous form. Let's do the balancing again. Here will be 2. And the last one, oxygen plus 2 molecules of hydrogen in the presence of platinum. It gives you 2H2O. This is in the liquid form. This is in the gaseous form. And this is, of course, the gas. Okay. So that means what is A? Nickel. This is your B and C is your platinum. So you have first option as the right answer. Hope you understood this. Let's move to the next question. 147. The correct statements regarding the froth flotation method in metallurgy are used for the purification of the sulfide ores. That's correct. This method is based, this is right. This method is based on the differences in the wetting properties of gangue and ore particles. The statement, first one is correct. Next one, used for question 147. The correct statements regarding the flotation method in metallurgy is used for the purification of the sulfide ores. This is absolutely correct. Used for the roasting of the sulfide ores. No. It is based on the relative densities of the gangue and the ore particles. No, it is based on the difference in the wetting properties of the gangue and ore particles in frothing agent and water. This is also correct. So that means you have first and the fourth options as the correct ones, which makes first option as the right answer. Hope you understood. Next is question number 148. X plus Y gives you oleum. The sum of oxidation states of the central atom in X and Y is. To understand like what an X and Y, I have to complete this. The sulfuric acid, when reacts with sulfur trioxide, it gives you oleum. That is H2SO7. And this is your sulfuric acid. And in the question, this refers to X. This is sulfur trioxide, and this in the question refers to Y. In both X and Y, the central metal is sulfur. Its oxidation number is +6. In both sulfuric acid and sulfur trioxide. So the sum of oxidation state of the central atom in X and Y, this is 6 plus 6, this is equal to 12. So you have first option as the right answer. Hope you understood. Next is question number 149. Which of the following has the highest molar conductivity? First one, dichloropplatinum 2. Okay. And the second one is tetraamine dichlorobalt 3 chloride, potassium hexacyanoferrate 2 or hexaquochromium 3 chloride. Among all the given options, the third one, which is potassium hexacyanoferrate 2. It has the maximum number of ions. This is 5. Thus, it has the highest molar conductivity. Let's see. This is K4. FeCN6 gives you 4 K plus ions plus FeCN6 4 minus. This is your potassium hexacyanoferrate. So you have C option as the right answer. Hope you understood. Next is question number 150. The formula for tris ethane 1,2-diamine cobalt 3 sulfate is let's write down the formula for this. So the formula for tris ethane 1, let's write it down. First of all, ethane, that means it is having 2 carbon atoms. So ethane, this is CH2, CH2. Then 1,2-diamine, this will be NH2. Here will be NH2. You have tris, so this is 3, tris cobalt 3, cobalt 3, so this is 3 over here. Sulfate will give you 2, and this is for tris, this 3 is for that. So that makes question number 149. Which of the following has the highest molar conductivity? Number 1, diamine dichloropplatinum 2. Then is tetraamine dichlorocobalt 3 chloride, potassium hexacyanoferrate 2 or hexaquochromium 3 chloride. Okay. See, among the given options, the third one, which is potassium hexacyanoferrate 2, has the maximum number of ions. This is 5. Let's see. So if I react to this potassium hexacyanoferrate, this is K4 FeCN6. This will give you 4 K plus ions plus FeCN6 4 minus. So it is giving you 5 ions over here. 1 and 4 and 1. That means this is your potassium hexacyanoferrate 2. So you have third option as the right answer. Next is question number 150. The formula for tris ethane 1,2-diamine cobalt 3 sulfate is. Let's make it. You have ethane, so that means 2 carbon atoms are involved. So CH2, CH2, 1,2-diamine. This will be NH2. There will be NH2. Then you have cobalt 3. So this is cobalt 3. Sulfate. So sulfate is having a valency of 2. This will be 2 and SO4 3. This is the right formula and D option. This is the correct answer. Hope you understood this. Next is 151 question. You have to identify the condensation polymers for the following: PHBV, Buna N, neoprene, nylon 6, or glyptal. See, the condensation polymerization involves this repetitive condensation reaction between bifunctional or trifunctional monomeric units. Thus, among the given polymers, question number 151, you have to identify the condensation polymers for the following: PHBV, Buna N, neoprene, nylon 6, or glyptal. Condensation polymerization involves a repetitive condensation reaction between bifunctional or trifunctional monomeric units. Monomeric units, thus among the given polymers, PHBV, nylon 6, and glyptal are the condensation polymers. That is ADE. Option D is the right answer. Hope you got that. Next is question 152. Sulfur-containing amino acids of the following are serine, cysteine, lysine, and methionine. Sulfur-containing amino acids of the following are, sulfur-containing amino acids are cysteine. This is given by CH2. Here is SH. And this is methionine, H3C, S, CH2, CH2. So you have B and D, that is question number 152. Sulfur-containing amino acids of the following are serine, cysteine, lysine, or methionine. Okay. Sulfur-containing amino acids are option B, cysteine. It's given by CH2. And here you have SH. And you also have methionine. This is given by CH2, CH2. So here will be H3. All right. So that means you have B and D. Option D is the right answer. Hope you understood this. Next is question number 153. Which of the following bases are present in both DNA, both in DNA and RNA? Okay, let's check out. This one, the first one, this is adenine. This one is adenine. The second one, this is uracil. Cytosine. This is cytosine and thymine. Adenine and cytosine are common nitrogenous bases that are present in DNA and RNA. So these both are present both in DNA and RNA, whereas uracil, that is B, is present only in RNA, and this is present only in DNA. And adenine and cytosine, they are present both in DNA and RNA. That makes option D to be the right answer. Hope you understood this. Next is question number 154. Food preservative sodium benzoate is eliminated from the body as which of the following metabolite? Okay. Sodium benzoate, it is eliminated from the body by combining with glycine, which forms hippuric acid, and then it is excreted. So you have hippuric acid, option D, as the right answer. I'm repeating, sodium benzoate is eliminated from the body by combining with glycine to make hippuric acid, and then it is excreted out of the body. Next is question number 155. Hybridization of positively charged and negatively charged carbons of the following respectively are. Okay. See, let's question number 155, hybridization of positively charged and negatively charged carbon of the following respectively are. See the hybridization of carbocation is sp2, which is in the first compound, and for the second compound, it is sp hybridization. So you have, looking at these, you have first option as the right answer. Hope you got that. Next is question 156. Which of the following is the general dichloride? 1,1-dichloropropane, 1,2-dichloropropane, 1,3-dichloropropane, or 1,2,3-dichloropropane? See, the general dihalides are the organic compounds containing two halide groups attached to the same, and two halide groups which are attached to the same carbon atom. Thus, among the given options, only one, because it is attached to the same carbon atom. So that makes option A to be the right answer. Hope you understood. Next is 157. This says the catechol and the cresol respectively are. Which of these options? Let's make them first. So then we will match it with either of the options. So first one, let's make it. You have this. Here is your hydroxyl group, and here is the another one. This is catechol. That's a benzenyl 2-diol. And the second one, sorry. So here you have OH and CH3. This is amcresol. This is 3-methyl phenol. So let's see, this matches with the option. Option D, this is the right answer for the question. Hope you understood this. Next is 158 question. What are X and Y respectively for the following reaction? So let's complete the reaction to understand what is the value of what are X and Y. You have CH3, CH2, CHO plus 2 copper ions and 1 hydroxyl. This will on reaction like this will give you CH3, CH2, COO negative plus copper oxide plus water. So according to the question, this is your X and Y respectively. Then you have D option as the right answer. Hope you understood. Next is 159. Which of the following is not correct about Grignard reagent? It is number 1. It is nucleophile. This is right. Forms a new carbon-carbon bond. Correct. Reacts with carbonyl compounds. That's also correct. It is organomanganese compound. No, this is wrong. Statement 4 is wrong about the Grignard reagent because this reagent is an organometallic compound. So you have option D as the correct answer. Hope you understood. Next is question number 160. This is the last question for the paper. Let's go for it. X and Y major products in the following reaction. So I have to complete the reaction to check what are X and Y. Let's do the reaction over here. So this is your ring, and here you have NH2 in the presence of acetic anhydride, and pyridine. It will give you this. Question number 160. This is the last question of the paper. X and Y major products in the following reaction sequence are. Let's complete the reaction to understand like what will come over here. Here is double bond, NH group, NH2 group over here. And reaction acetic anhydride, pyridine. This gives you Here will be NHCOCH3. And this further on reaction in the presence of bromine and CH3COOH, this will give you this ring. There will be NHCOCH3 and a bromine will be added over here. So this is your X and this is your Y. Looking at that, let's check with the options. This is the one. Option D stands to be the right answer to the question. So students, with this, we have completed all the 40 questions of the chemistry part for this paper. Hope you understood them well, and don't forget to visit our website www.examsnet.com. Here you will find not only this, but similar type of multiple entrance exam question papers for your better preparation of the exams. Also, you must download our app. The link is available in the description box. So students, keep shining, keep rising high. That's all for this paper. Best of luck. Bye.